Hello, Mr. Vessel here, and today we are going to be looking at the 2019 AP Stats exam, problem number 2, and the theme of this task today is experimental design. Specifically, we'll look at some terms within experimental design and how to describe a random process for setting up treatments. So, hopefully this video comes in handy for those looking at studying for AP Statistics, and let's dive in here. So this problem starts with description about researchers are investigating the effectiveness of using a fungus to control the spread of an insect that destroys trees. Researchers will create 4 different concentrations of fungus mixtures, and we get the values here: 0 milliliters per liter, 1.25, 2.5, and 3.75 milliliters per liter. An equal number of insects will be placed into 20 individual containers, and the group of insects in each container will be sprayed with one of the 4 mixtures. The researchers will record the number of insects that are still alive in each container 1 week after spraying. And the first task: identify the treatments, experimental units, and response variables of this experiment. So just knowing some terms and what some of these things mean. The first one we're going to look at are the treatments. In general, treatments are what we impose as our explanatory variables here. So what we think is these different mixtures will have an impact on insects. So we got to list these out here. So the treatments are 0 milliliters per liter, 1.25 milliliters per liter, and 2.5 milliliters per liter. Oh, sorry, one more, and 3.75. And these are fungus mixtures. I'm going to even be a little more specific. They're the 4 concentrations of fungus mixtures. And then the next thing we're looking at is the experimental units, and this one is often incorrect from a lot of students. A lot of students will say it's the insects. It's not the insects. It's the 20 individual containers that are experimental units. Now you can say like groups of insects in the containers, that's okay, but you have to mention that it's this group of containers, and we're putting the treatments in the containers, and the insects just happen to be in them. So the experimental units are these containers, not the specific insects. So the experimental units are the 20 containers, and you can, like I mentioned, 20 containers of insects is fine, or even equal number of insects, but it has to be about the containers. And then the final thing is what we're actually measuring. So the response variable, and again, we don't want to just say alive or dead. We want to be more specific. What they're going to measure, the number of insects that are still alive in each container. So we're just going to be really specific with this. And 1 week after spraying. And the next part looks at specifically a control group and what that represents in this case. So does it have a control group? Explain your answer. And this one does. And where we see this is right here. We have this mixture of fungus that has 0 milliliters per liter. So that represents a control group here. So we want to, well, first part of the question, does it have one? Yes. The group of containers that receives the 0 milliliters per liter mixture of fungus is a control group. So we'd know what would happen if there wasn't any fungus at all. And then the final one, and maybe this one is the one that requires the most time and energy on. It says describe how treatments could be assigned so that to the experimental units, so that each treatment has the same number of units. So when we do something like this, we got to be really specific. It's got to be at a level where if you gave these instructions or steps to create this experiment, that someone else could execute them. And a couple things that are really important about these randomly assigned. So when you see the randomness, we got to make sure that we set something up so that each of these containers has an equal likelihood of being chosen for the treatments, and we could just have to give it a level of specificity that someone can execute our steps. So there's lots of ways to do these. We could use a random number generator. We could use dice. My favorite, I think, and something that students tend to cling to is, if you can, and while it might not be realistic, it might take a long time in some cases, using like a hat or putting treatments on a piece of paper. That's often something that students like because it makes sense to them and it works. It will give you randomly assignment. So what we're going to do, I'm going to quote that method in this case. Like I said, there's lots of ways to get full credit for these. But what I'm going to try to do here is describe how I would randomly assign how the treatments can be randomly assigned to the units so that each treatment has the same number. So there's a couple things I want to keep in mind. There were 20 containers, so I want to make sure that I've got these 20 containers, and since I've got 4 different treatments, I'm going to have 5 different treatments in each. The treatments will be used 5 times in total. So let's start by labeling. Let's label our containers 1 to 20. And this part isn't random. We don't really care about the randomness. I just want to make sure that when we do grab our treatments that we assign them to a specific container. So next, let's put the 4 treatments on 20 slips of paper, and this would be 5 times each. And what this will do is we're going to put these pieces of paper in a hat. We'll just pull out one piece of paper for each of our containers, which will randomize our treatments. And the purpose of randomization is this will allow us to make determinations that it's really about the treatments that are causing some sort of, in this case, response variable of the number of insects that are still alive. And in this case, put the 4 treatments on 20 sleeves of paper. So we've got, and I can even be more specific, we got the 0, 1.25, 2.5, and 3.75. So we could just put these on our sheets of paper 5 times, and then for the first container, oh, I forgot a step before the first container. Put the 20 slips of paper in a hat, and for the first container, select a piece of paper from the hat, and then use that treatment in container 1. And then we're going to repeat this for the next 19 containers. And this will end up giving us our, so this will randomly place our 4 treatments 5 times into the 20 containers. And then after a week we can measure what we want to measure, but we don't have to do that with Part C. Part C just says describe how the treatments can be randomly assigned. And we've just done that, and that's all there is to that. Just making sure that you have given out some steps that could be executed and that it is random, and that we're using the treatments in our experimental units. So this was the 2019 number 2, and hopefully this comes in handy when studying for some AP statistics. Thanks for listening, and check out some other AP statistics videos.